Hey everyone, welcome back. This is our second video on Apache Ignite. While the first one was completely about the fundamentals, in which we covered the features, the main use cases, and some of the key concepts related to Apache Ignite, how Ignite does what it does. In this video, we will focus on the hands-on. We will see how to set up Ignite on a local machine, how to run an application with Apache Ignite. More specifically, we will be focusing on using Ignite as a cache. So how do we start? We need a project to start. For this demo, I will use a simple Spring Boot project, although we don't need any Spring capabilities or any Spring project, but still I'll go with this one so that it's easier to show how to integrate Apache Ignite with, let's say, a Spring project. Let's go to the Spring Initializer. This is going to be Java and Maven project, current version at the time of recording. And we will provide the required details. And that's it. We don't need any other dependency in order to start with Apache Ignite. So let's generate the project and I'll open it with IntelliJ. So here I have unzipped the project and let's open it with IntelliJ. Give it some time while it downloads the dependencies and sets up everything. So the project setup is complete. If we check the pom.xml, we don't have any Ignite specific dependency as of now. Now there are two ways to run Ignite. The first one is to run Ignite as a separate server, as a separate process. So let's say you can run Ignite via Docker, or you can download the executable and start the Ignite server. Then all the applications would connect to that Ignite cluster to work with Ignite. And the second thing is we can run Ignite in embedded mode with the application. So that means we don't have to run any other server, Ignite specific server. When you run the application, Ignite will start itself with the application and that will share the memory of the same application. So let's say your Java application is running with 4 gigs of memory. Out of that 4 gigs of memory, some memory will be allocated to Ignite. So that is Ignite running in embedded mode with the application. And we will be following the second approach, which is to run Ignite in embedded mode. To do that, we have the application. We need to add the Ignite specific dependency. Where do we find that? We can go to the official documentation of Apache Ignite. This is the landing page. And here, if you go to the docs, this is the Apache Ignite documentation and you can select a particular version. This is the latest one at the time of recording. However, there is one beta version available, but I will go with the stable one, which is 2.16. And here you can go to the quick start guides. And this is the quick start guide for Java. So scroll down. And this is the dependency that we need. For now, Ignite core is the only dependency that is required. So let me copy this one. We'll go to the pom.xml and we'll add the Ignite core. And the version of Ignite core is 2.16. Here it is. Save the pom.xml and reload the project. It will now download the Ignite code dependency. Now we have the Ignite dependency. What else we need to do? We need to run the application, and when the application is running, we need to initialize the Ignite. So let's go to the main class. Here it is. And for now, we will add a new bean, which is the application runner. This is plain Spring Boot, has nothing to do with Ignite. All right. And once we have the application runner, how do we run the Ignite? We do that by calling a class which is ignition.start. That's all. So when we run this code, when the application runner gets executed, it will call ignition.start, which will initialize the Ignite. So as the application is coming up, Ignite will also start and we should see the Ignite up and running in the same application. So let's do that. Let's try to run this application. And here we see an error. Let's check out the error. It says that unable to make field this accessible module java.base does not opens java.nio. So it has something to do with JDK. Now, if you check out the guide, quick start guide, there is a section called running Ignite with JDK 11 or later. So if you have JDK 11 or later, you need to follow the corresponding steps. We need to open the packages. So because I'm running JDK 19, so I can follow this one, JDK 17 one. Let me copy all of these. Here you can see this is opening the required packages to all unnamed modules. This is JPMS, Java modules. So let me copy this one and we'll go to the run configuration here. And in the run configuration, we need to provide these VM arguments. So let me enable the VM options, and here I will simply copy all of them like this, hit apply and OK, and let's rerun the application. And here you can see while the application is coming up, Ignite process is also getting started. So we see all these things related to Ignite. And notice the log message which says node started. So as we started the application, it also started a new node of Ignite. And notice the topology snapshot which says version 1 local node, the address or the ID of the local node, and there is one server. By default, the nodes are started in server mode. So there is one server node and the status is active. Okay. So this is Ignite up and running with the application, and the available heap to this Ignite is 4 gigs. Now this application is doing nothing. It's just starting the Ignite. Let's do something useful. So as I said, we will be focusing on using Ignite as a cache. How do we create an Ignite cache? Now, if you notice when we call the start method on the ignition class, it returns something called Ignite, the object of Ignite. And you can say this is the entry point to Ignite. Whatever we do with Ignite, this is the class that we need. So we can store the reference variable like this. And let me import this one. Now, in order to create the cache, we can use this variable ignite dot, and you see all these methods are available. Whatever Ignite supports is available here. This is the one that we need, get or create cache. That means when we call this method, it will either create the cache if it doesn't exist, or it will reuse the same cache if it exists. So let's create a dummy cache for now. And we will store the cache in a variable which is Ignite cache. And notice we can also provide the type parameters for key and value. So let's say we provide the type parameters to be string. So here we have an instance of Ignite cache. What can we do with this cache? If we check out the methods provided by Ignite cache, we see these methods look familiar. If we check out the videos of, let's say, caffeine or guava or any other cache, the methods look familiar. You get methods to add the entries, you get methods to get the corresponding value, to clear the entries, to iterate the entries, and so on. And that's what you see here: get all, the async version of some of the methods, and all that. So let's add an entry, a dummy entry with key1 and value 1. And to test the code, we can then fetch the same entry by key1. So what we are doing, we are starting the Ignite. Then when the Ignite is up, we are creating a new cache by calling the method get or create cache. Now at this point, because there is no cache with the name dummy, so Ignite will create a new cache, right? And once we have the instance of the reference variable of Ignite cache, we can call the corresponding methods to add the entries, and here then we are fetching the same entry by key. So if we rerun the same application, if everything goes fine, in the output, we should see the value 1. Okay, so let's restart the application. So the application is up, and if we check the logs, we see the message like started cache. This is the cache that we created here. And then we see some log messages related to partitioning and how it completes the partitioning exchange. So if you remember the earlier video where we talked about the partitions here, it is not only creating the cache, but as per the default configuration, it is assigning the cache to, let's say, some node to store the data. But because in this case we have a single node, so nothing to worry about. And in the end, we see the log message value 1. That's what we did here. Here we try to read the entry by key 1. So it is returning the value, the corresponding value. That means we successfully created an Ignite cache. We added a new entry to this cache and later we fetched the same entry. So here we have a very simple Ignite cache running with the application. Here I want you to notice one thing, which is this Ignite directory under project. Now this is something we did not create, but it was created by Ignite. When we run Ignite in embedded mode, by default, it creates this directory under the project structure. Why does it need the work directory? Because Ignite has to store the data, whether it is metadata or the actual records which are there in the Ignite cache, it has to store them. And to store them, it uses the work directory. If we check out this directory, we see the structure Ignite work DB and then this alphanumeric hash code kind of structure, which is the actual node ID. So here we have a single node running, and that's why we see this alphanumeric code, which is specific to this node ID. So everything that is related to this node, Ignite has to store, it will go under this folder. This is the node ID. So coming back to the code that we have written, now in a real application, Ignite, you will start Ignite only once. And once we have the Ignite up and running, once we have the access to this object, we would want to inject this object wherever we want. We don't want to start the Ignite again and again. All right. So what is the correct approach of doing that? If we are using, let's say, a Spring application, then we know we have the concepts of beans. So we can have some bean methods to do one-time initialization. And once we have the object, we can inject it anywhere using auto-varying. So let me refactor this code. We will write a new bean method here. Now, because this is a Spring Boot application and we know the main class is already annotated with @configuration annotation, so we can write new @bean methods in the same class. We will say public and this will return Ignite. We can name it whatever we want. And in this method, we will say return Ignite. And once we have initialized the Ignite, we will return the Ignite object from this bean, and this can be injected anywhere. So for this demo, we can inject this object in this particular method, and it will be auto-vared by default by Spring Boot like this. And so we can treat it as any other object. Once we have the access to that instance variable, we can do anything that we want, which is supported by the object. So what did we do? We refactored the existing code. We moved the ignition part to another bean, and then we are injecting the Ignite object to the previous bean where we are creating the Ignite cache. So if we rerun the same application, we shouldn't see any other change, any impact on the running functionality. If it works fine, that means this is also working fine. So let's restart the application. So again, we see the same value 1 on the console. That means it's all working fine. Okay, so let's move on. Now that we have successfully initialized Ignite, how do we configure it? We know Ignite is highly configurable. We can configure a lot of things like work directory, persistence, whether the native persistence is enabled or not. We can also configure the backups, the partitions and everything. How do we do it? Well, when we start the Ignite, we can also provide configuration to the start method by using something called Ignite configuration. So this class comes from the Ignite code dependency that we added. So we can have Ignite configuration. We can provide the configurations to this object, and then this object will be passed on to start method. So let's try to do that. We have Ignite configuration like this, and then we pass the Ignite configuration to start method. Now we can configure Ignite as we want. We have Ignite configuration, and whatever configurations we set in this object will be applied to the Ignite. So if we check out the Ignite configuration, we have a lot of configurations available to us. If we simply type set, you can see all these set methods. So there we have something called cache configuration, data storage configuration, cache key configuration. We can set class loaders, for example. We can make an Ignite client. So we know by default an Ignite node starts up as a server node. We can change it to client by calling this method set client mode true. Then we have methods to set the discovery API, deployment mode, consistent ID, failover, and so on and so forth. Now, this is very difficult to cover each and everything, so we will be focusing on important bits. Now, if we go back to the previous video where we covered the fundamentals, there we talked about the memory architecture of Ignite. We know we have something called regions, data regions. Each region has segments, and then the segments have, let's say, the data pages. And we also talked about that Ignite caches belong to a data region. There are some configurations that can be applied only on the data region. So for example, we have to set eviction mode that can be done per region. So we need a data region. If we don't create one by default, a default region is created. And whenever we create a new cache, that cache will be mapped or stored on that data region. And that's what's happening here because we have not created any data region. There will be a default data region that will have this cache that we created. So let's say we have to create different data regions. Why would we create different data regions? So there could be a scenario, something like, let's say we have two caches. For one cache, we want to enable the native persistence, but for the other cache, we don't want to enable the native persistence. We want to keep it in memory. And how do we achieve this? That's where data region comes handy. So let's say we create two data regions and we create two caches. We know caches are mapped to data regions. So for one data region, we will enable the native persistence, and the cache that requires the native persistence will be created in the data region 1, for example. And the second data region will have the second cache for which native persistence will be disabled. Or maybe we want to have different eviction mechanisms. Now we know eviction mechanism is applied on the region. So again, we can have multiple regions and then we can apply different eviction modes on different regions. How do we create the data region? We do this with the help of something called data storage configuration. So if you notice, Ignite configuration has something called data storage configuration. And by using this configuration, this property, we can create or provide a data storage configuration. So let's try to use it. Data storage configuration. How do we create the data storage configuration? We need to create it first. So here it is, data storage configuration, DSC equals to new data storage configuration. All right. Let's see what this data storage configuration allows us to set. So if we check it, dsc.set, again, we have many properties related to data storage configuration. So Ignite configuration has data storage configuration, and data storage configuration in turn have many other properties that will allow us to configure data storage configuration. And here we have something called default data region configuration. So a data storage configuration would have configurations related to different data regions, and we will use this one to redefine the default data region. Let's use this one. It stores or it requires something called data region configuration, data region configuration. To do this, we need to create a data region configuration now. Data region configuration, we'll name it drc equals to new data region configuration. So far, we have created an empty drc data region configuration. We are setting this data region configuration in the data storage configuration here. And then we are passing this data storage configuration to Ignite configuration. And finally, this Ignite configuration is passed on to ignition.start. That will start the Ignite server. So let's configure the required properties in this data region configuration. We say drc.set, and here we see lots of properties again. So for example, set name. Let's name it my data region. What else can we configure? We have drc dot, let's say, set initial size. So we can set initial size for the data region. Let's say we want to start with 10 MB, 1024 into 1024. So this is the initial size of 1 MB. We can also set the maximum size that this data region can expand. Let's say we say the max size for this data region could be 40 MB. So now you see, depending on the caches that we want to create, we can define different data regions and we can provide different memory arguments to those data regions. That kind of flexibility we have with the help of Ignite configuration. Let's see what else can we configure. So we have something like eviction threshold or set page eviction mode. This is the one we were talking about. How can we configure eviction modes per data region? So let's say we want to set the eviction mode. So that will require data page eviction mode dot disabled random LRU random to LRU. So we'll pick this one. So here we have configured a data region with the name my data region. These are the memory constraints of that data region. And we have also set up a page eviction mode, which is random to LRU. And this data region configuration is going to the data storage configuration, the data storage configuration to Ignite configuration, and Ignite configuration to ignition.start. So there's a lot going on in this method. We can refactor it further. So let's say we can move it to some other method to keep it clean, and we'll extract the method like this. All right, we'll name it get storage configuration, and then we can call the method directly from here like this. So we didn't do anything special. We simply moved everything to a new method, get data storage configuration. And this particular method will be focusing on just the Ignite configuration. So we have successfully set data storage configuration. And now if we run the application, let's see what happens. We see the correct output, which is value 1. And if we see here, started cache, this is the name of the cache that we created dummy, and ID data region name. So notice in this log message, the data region name is my data region. And this is the one that we created. This is happening because we created a data region and we set it as a default data region. And that's why the cache that we created will automatically be mapped to the data region with my data region. All right. You can check out the mode of the cache, which is partitioned, the atomicity, which is by default atomic, and you can see the backups at 0. Now the second thing that we will see is how can we configure the cache itself. We have successfully configured the data region with the help of data storage configuration. How can we configure the cache? Because if you remember, we talked about different caching modes like replicated and partitioned. We talked about the atomicity like atomic and transactional. The backups, we should be able to configure the backups for the cache. How do we do that? Well, let's check out the Ignite configuration again. Let me stop the application. So let's see what else is available for us. Here we have this method set cache configuration. Now this method is used to provide a cache configuration to Ignite configuration. So the cache will be created according to this configuration. Let's use this one, set cache configuration, and following the same pattern, we will create a new method, get cache configuration. Let's create a new method like this. And in this method, we will start writing the cache configuration. So this is the class that we need. Notice the type parameters. We can provide the type parameters. This is a simple demo. So I will simply pass string, but in a real application, you want it to be generic. It should be able to support generic caches with the help of generic type parameters. But this is fine for now. So this is cache configuration equals to new cache configuration like this, and we will return the cache configuration. Okay, so let's see what is available in the cache configuration. If we call cc.set, we see the data region name. That means now we have the control to map an Ignite cache to specific data regions. If we don't select any data region, it will be by default mapped to default data region, which is happening. So let's ignore this one for now. We can also set on heap cache enabled. What it will do, it will force Ignite to cache everything on the heap. That means on the Java heap. When we enable this configuration, that means Ignite will store the data on Java heap. Now we know when we store the objects on the Java heap, the size will grow, and when the size will grow, GC will run. So that means whenever we store the data completely on Java heap, when we enable this configuration, we may trigger GC more frequently. It may or may not impact the garbage collection mechanism. So if you don't want to do that, you may choose to disable this configuration. I'm just showing this. So we can set something called on heap cache enabled just for the demo. let's say we want it to be false. Then we have backups. So let's say we say I want one backup, although we have a node, a single node, but let's say we're simply setting the property to set backups as one. Then we have something called set cache mode. And here we can provide whether the cache has to be partitioned or replicated. We saw earlier that by default it is partitioned. So let's override the property and make it replicated so that we can check the logs. Then we have something called atomicity mode. By default it was atomic, but we can override it to, let's say, transactional, and so on and so forth. So lots of configurations available here. We may choose some of them depending on the use case, but let's ignore everything else. This is sufficient as of now because we want to show how to provide the cache configuration. So we have created a cache configuration object. We are setting it to Ignite configuration. All right. And now let's start the application and let's see if it changes anything related to the existing cache. And we got an error. It's saying that argument is invalid. Cache name must not be null or empty. I missed this one. So we need to provide the name of the cache, which is the mandatory parameter. So we will say set name and dummy. So that defines for which cache we are providing the cache configuration. All right. And let's rerun the program. So we see the correct output, which is expected. Let's check if we can see any changes in the dummy cache. So if I search dummy, here I see the data region, which is expected. Now we see the updated mode, which is replicated. Earlier it was partitioned, and the atomicity as transactional, which is by default atomic. So that means here we have successfully configured or used the cache configuration object to override some of the configurations. Now, if you notice, we provided the name dummy in this cache configuration, and later we asked Ignite to create a cache with the same name. What if we create another cache? Would Ignite apply the same configurations to the new cache? Let's check out. So let's say we create a new cache for which there is no cache configuration, and we keep everything same. Cache 1 equals to ignite dot get or create cache, and we give it a name dummy1. All right, and let's restart the application. And the application is up. Let's search for dummy1. Here it is. And notice the properties of dummy1. So for the dummy one, we see the data region because that is the default data region, but we see the mode partitioned and atomicity as atomic. That means for the new cache that we created, Ignite did not apply the same cache configuration. So that means cache configurations are also cache specific. The name that we provide, if we are passing the same name to the Ignite to create or to fetch the same cache, it will apply the cache configuration. Otherwise, the default configurations will be applied to the new cache. So that means we need to have different cache configuration objects for different caches in case we want the behavior of those caches to be different. All right. Now, the next thing we will see is what if we enable, or how do we enable the persistence? So till now, so far what we have seen that we have created the cache, the Ignite cache is storing the data, but this is completely in memory. How do we check it? Well, let's see. Let me stop the application first. So here what we are doing, let me comment this one as well. We don't need it anymore. So here what we are doing, we are creating the cache, then we are putting some data in this cache. All right. And later we are fetching the same entry. So if we run the application again, we see the value 1. But what if we comment this out and restart the application to mimic the scenario what happens when the node goes down? So we know we stored the entry in this cache because we can see the output. But what if we comment this code and restart the application, because we don't want to put the same thing again. We want to simply fetch the value to see if the value is still available. So let's restart the application. Let's say the node crashed and restarted. And as you can see, the value is null. That means if the node restarted or went down, we would lose the data because this is completely in memory. This time when we restarted the application, we commented this code. That means there is no one putting the additional data in this cache. Ideally, we would expect the data to be available, but because this is completely in memory, when we restarted the application, the data is lost. And that's why we see the value null. Well, that's where we can enable the native persistence. In case we enable the native persistence, what happens? Ignite will store all the data on the disk, and simultaneously it will pull as much data as it can in the memory. So the operations will be served from the memory, but as a backup, the data will be stored on the disk. So how do we enable the native persistence? But first, let me uncomment this one, stop the application. Let's see if we can do it on the cache level. So here we say cc.set persistence, or let me simply search for persistence. We don't see any method related to the persistence. That means we can't set it on the cache level. What if we check out the data region? Because we know many things are data region specific. So here if we see dot persistence, there is a method, there is a configuration related to data region which says set persistence enabled. So we can enable the native persistence on the data region level, and all the caches which belong to this data region will get the benefit of native persistence. That's it. That's all we want. We simply configured or set the value to true of persistence enabled on the data region level. Now let's start the application and notice first we will put the value in the cache. All right. And here we see an exception. It says cannot perform the operation because the cluster is inactive. All right. What is this? What is this error? It says that the cluster is considered inactive by default if Ignite persistent store is used to let all the nodes join the cluster. That means when we enable the native persistence, by default the cluster is considered inactive because it doesn't know how many nodes are going to join. So we have to activate the cluster explicitly. How do we do that? Well, we go to the Ignite, and here if we check, we should have something called state. Do we have something called state? No, it must be under cluster dot state active, because we have only a single node, and once we have the Ignite object, we want to activate the cluster immediately. Let's rerun. And there we have it. We successfully started the application and notice the correct output, which is value 1, which is expected because we are putting the data in this Ignite cache. But because we enable the native persistence now, that means Ignite should store this cached entry on the disk as a backup. To test it, now if we comment the value and rerun the application, so when we rerun the application, this code will not be executed, but this code will be executed, and the native persistence is enabled. So if everything goes fine, Ignite should be able to read the entry from the disk. We should not lose the data in this case. So we have commented the entry, and let's restart the application. And there we have it. We see the correct output value 1. That means even though we did not execute this code, we did not put the entry explicitly, cache is able to read the entry from the disk, from the memory, because we enabled the native persistence. And notice the change in the Ignite work directory. Earlier, there was a single folder with the hash code or similar looking code of the node. But now in this folder, we have additional folders like cache dummy, cache ignite syscache. Now notice this is the name of the cache dummy. We created the cache with the name dummy. So when we enable the native persistence, Ignite will store the data for the cache in the work directory. And that's what we see here because we enable the native persistence. And that's why it was able to read the data from the disk. So far, we have covered a lot of things related to Ignite caching. And I hope this is more than enough to get you started with the Ignite. Of course, there are a lot of things to cover, which we will cover in future videos. So I will see you in the next video and thanks for watching.